Ever wondered how data travels across the internet? It's a bit like navigating through a bustling city. It needs a good map and a savvy guide. And in the vast metropolis of the internet, that guide is the Border Gateway Protocol, or BGP for short. Imagine BGP as the GPS of the internet. It helps routers find their way, choosing the most efficient routes for data to travel between networks. It's the protocol that keeps the world connected, making sure your email reaches your colleague in Tokyo or your message gets to your friend in New York. So, how does BGP work? It's a process that can be broken down into 5 states. First up is the idle state. This is the starting point, where the router is trying to establish a connection. Next is the connect state, where the TCP connection is being set up. This is followed by the open sent state, where the router is sending out its capabilities. The 4th state is open confirm, where the router has received and accepted the capabilities of the other router. Finally, we reach the established state. This is where the routers are fully connected and start exchanging routing information. Now let's delve into some key BGP attributes. Firstly, there's the next hop, which is the IP address that will reach a particular destination. Then there's the AS path. This is the path a route takes through different autonomous systems, or AS. The origin attribute indicates how a route was introduced into BGP, whether through IGP, EGP, or it's incomplete. The local preference attribute is used to select the exit point out of multiple options. And finally, the wait attribute, which is a Cisco-specific attribute, influences the best path selection. Configuring BGP involves several steps. First, a unique router ID is assigned for router identification. Neighboring connections with other routers are established. Networks to be advertised are specified in network advertisement. And finally, filters are applied to control route advertisement. But what happens when things go wrong? Troubleshooting BGP involves a few key steps. Checking neighbors ensures routers are connected and in the established state. Reviewing the route table ensures the BGP table has correct routes. Logging involves analyzing logs for any error messages or warnings. Packet capture uses tools like Wireshark to capture and inspect BGP packets. And finally, a configuration check verifies that BGP configurations match on both ends. So, there you have it. BGP, in a nutshell, is the internet's traffic director, steering data efficiently across networks. By understanding and mastering BGP, you're essentially guiding the internet's data traffic. Remember, the internet is a vast and complex landscape, but with BGP as your guide, you're well equipped to navigate it. Stay tuned for more networking insights on this channel. Stay curious and keep exploring.